Well, hey there, kiddos. It's time for the last example in exponential functions, growth and decay part 3 on day 2. And so if you would, either pull up your notes that you've printed off or use the Google slide and let's go through. This is, let's see, this is page 4, or I think slides 8 and 9. So we want to go through and decide the second thing. The first objective of our lesson was determining growth or decay. And we just went through some examples on that. We know that an exponential function is growth if the base is greater than 1, and it is decay if the base is between 0 and 1. It's not negative, and it's not ever equal to 1. So what we do need to decide is what are these other parts of, um, of the function? What are these other parts? Alrighty, so I'm going to pull up my pen, and here we go. The general equation for exponential growth. And again, we know it's growth because of the value of b. A, and that's the number out front. If we don't see a number, it's understood to be 1. Okay, so A is the initial or starting amount. If we were looking at a table, we would say, hey, when x is 0, what's y? All right, that's the A. So when x is 0, that amount right there, that's the y value, okay, which we'll say is A in here, right? The initial, when x is 0, the amount that y is goes right there for A. Okay? Initial or starting. If b is greater than 1, then this is, of course, exponential growth. And what's it going to look like? Well, the curve is going to look something like that. And B is called the growth factor, right? That's what B is called, the growth factor. And B is going to be equal to 1 plus R. Okay? 1 plus R. And R, you're like, wait, I'm looking up here. Y equals AB and X. I don't see R. I just see AB and X. You're right. So how do we get B? 1 plus R. And who is R? That is the growth rate. How do we find R? If I know B, how do I find R? R equals, well, he's right here. This is a literal equation. How could we get R by itself? We'd subtract 1. Mm-hmm. This guy is what you multiplied by your Y column each time, all right? That is your growth factor. So that is the common ratio that you multiply down by the Y column each time. That is exponential growth, all righty? So if you need to press pause or do a screenshot or something, go right ahead. But we are going to go down and talk about now decay, all right? So how is decay different? Well, A is still the initial amount. If you were looking at a table, when x is 0, what is y? This says if b is greater than 1, and that is a typo, so I am so sorry. It should say that b is greater than 0 but less than 1. So that is a typo. So if you're typing in your values right here, I would just type in b is less than 1. Okay. When b is between 0 and 1, what is that? That is decay right there. When this number, the base, is between 0 and 1, a fraction or a decimal, righty? That's decay. And b is now the decay factor. And how do we find b? Well, if we're decaying, when we were growing, we were adding to get that. Now that we're decaying, decay means we're getting smaller, so we are subtracting. B equals 1 minus r. And r is the decay rate. It is the decay rate. And when we rearrange these, if I subtract 1, I've got b minus 1 equals negative r. Then we'd have to divide everything by negative 1, and we would get r equals 1 minus b. And a lot of times when we express r, we do it as a percentage. And so when we get a percentage, we multiply this value by 100. So if we wanted to write it as a percent, we would say 100 times r percent. And I'll show you that in the example in just a minute, right? So that's decay. Decay is when the base is between 0 and 1, and we get it by subtracting the rate. So let's just jump right in and look at some examples. All right, I'm going to do one example of growth, and I'm going to do one example of decay. Well, let's see. The base is 1.8. So is that growth or decay? It's growth. Let's go ahead and do example 1. All righty. I'm going to look right here at the base to determine if it's growth or decay. And since this number is bigger than 1, this is exponential growth. Initial value. All right, well, look, scroll back up at the top. That is the A right here. Right here. What is your initial value? That is 3. A equals 3. That's how many you had at the start. You had 3, right? When x is 0, anything to the 0 power is 1, and 3 times 1 is 3. So there you are. The growth or decay factor. All right, this is talking about B. So B equals 1.8. The growth or decay rate. So now I want to know who R is. And if you look back in your notes, we said that I could get R when it's growth. I can get R by saying B minus 1. So R equals B minus 1. So 1.8 minus 1 equals 0.8. So my growth rate is 0.8. Now we're going to multiply that times 100, and we get 8.8, or 8 tenths times 100 is 80%. 80% growth rate. That's huge. Okay. It's almost doubling. All right. So if we look at this one, same kind of thing, growth or decay, look right here, think about it, initial value, there's A, growth or decay factor, who is B, growth or decay rate, who is R. Since this number is greater than 1, it is growth. All right. So we're going to now look at, if you need to press pause and write some things down, go ahead. Otherwise, we're going to move on and look at look at number 3 and see what it looks like. Okay. Alrighty, on this particular page up at the top, and mine's a little bit cut off in the example, but again, it says identify the initial value, the growth or decay factor, the growth or decay rate. So all of these are exponential functions. I just need to break apart the pieces. And I think I want to do number 4, if that's okay with you. So let's decide, growth or decay. We're going to look at B. This is B, this is A times B to the X power. So I'm looking at B, and look at this, 0.94, that is 94 hundredths. Is that greater than 1 or less than 1? It's less than 1, just a smidge, less than 1. So if it's less than 1, it's going to be decay. Right? Initial value, that's the A. At the start, what is this worth? When X is 0, well, 0.94 to the 0 power is 1. 2 times 1 is 2. The initial value, which is A, and he's right out front. So A equals 2. The growth or decay factor, well, we already know it's decay. And what is that? That is the B value. B equals 0.94, which is 94 hundredths. The rate, all right, the rate. So how do I get B this time? Well, clearly I'm not adding it to 1. I don't add 1 to R to get B because this is less than 1. So how do I get B this time? I subtract R. So what did I subtract from 1 to get 0.90, to get 0.94 or 94 hundredths? Here's how we write it down. R equals 1 minus B this time when it's less than 1. All right, R equals 1 minus, and a good way to think of this is money. You have $1 and you subtract 94 cents, you have 6 cents left. So if R equals 0.06, let's multiply that by 100 and we get 6%. So again, on decay, the base is less than 1. My initial value is out front still, the 2. The decay factor is the base, that is B, and the rate with which it's decaying is 1 minus 94 hundredths, which is 6 hundredths. I multiply that by 100 and I get 6%. So in this lesson, we've looked at deciding whether it's growth or decay, and we learned that that's determined by B. And then we looked at breaking apart the equations to determine the initial value, the decay factor or growth factor, and then R, the growth or decay rate. And you've done such a good job. I appreciate you listening and staying with me. And we will continue to look at exponentials. And next week, we will start comparing linear, quadratic, and exponentials and do some application problems. So I hope you have a great weekend, and I'll see you back soon.